Why don't we get started today? Um, just a quick announcement. I posted some jobs again to send out email, but also to the announcements here. There's still time to look for a summer internship, and if you're graduating, there are still some opportunities for entry-level jobs out there. I've been looking for them here. One thing I'll note is that with these I'm mainly looking for jobs in Minnesota because that's where most of our students are looking. But I do post jobs other places. What often happens is that I look for a posting like Boston Scientific has a business analyst entry level job in Arden Hills. But while I'm there, I'm also seeing that they have a software development internship in Cambridge, Massachusetts. So as long as I'm at the site and I see another job, I'll post that here for that. Now, if for like machine learning people, even if you're not a computer major, if you're doing like the data analytics minor, there are some jobs here for that. So like the Excel Energy just announced their data visualization and management intern here. And that can be in either Minneapolis, Eau Claire, Wisconsin, or Denver, Colorado. Spent a few years in Denver. I strongly recommend it. If you can get to Colorado and live there for a while, it's well worth it. So Eau Claire is a fine town too. But uh, okay. So keep looking for internships and stuff like that. If you don't have summer plans, keep that in mind. Okay, let's figure out what we're doing this week. Um, So we're going to go through and do the learning activity today. We did part one on kind of Tuesday, and today we're going to work through part two with this learning notebook. I've updated the learning notebook and got it working here. Just to note, I updated the learning write-up a little bit too for part two. As I was going through and updating the notebook, I also noticed that some of the questions in the write-up weren't really that clear for students, so I updated them. You can keep using the original version of the write-up. If you find part two parts confusing, feel free to click on this link again and look here and just copy the updated part two if you want. I want to do this so that next year I have the updates there too. But I thought for some of you it might help. But so I'm going to go in here, go to the learning notebook, open that up, and start running that here. We're going to try to look, it's like last Tuesday we looked at like no code versions like Notebook LM, where you could bring in documents and you can ask questions of those documents. And that's really common now in businesses because a lot of businesses have their their own documents, their own stuff, and they want to use AI with those documents, with those things. And so this, what we call retrieval augmented generation. So we retrieve data from a data store and use that to augment our LLM, our generative model, is very important in industry now. And we're going to try to look under the hood in code and see how those models kind of work. And that's our goal today. This comes from a video tutorial by Underfitted here, which is a good tutorial. Let me get through this commercial here, it looks like. So again, this is Underfoot walks through this. He's doing this not in a notebook, but in VS Code, and you can do Python systems there and kind of open this sort of stuff and do it there. But we're doing it in a notebook similar. This is also over a year old, so I had to update quite a bit of it. One of the things we see is that in machine learning, the libraries are updated so often that any example that's a year old isn't going to run. And that's why it always takes me a while to get these things up and running. here. But again, so if you're interested, this is actually a pretty good tutorial that walks through this whole thing, walks through the code. Again, the code won't match exactly, some of the syntax is slightly different, but again, the main idea of the code is still there. It's an over hour long video. So even on speed and a half or whatever you like to watch your videos on, it is still a long video. What I've done is I have copied some of his great diagrams in here. And again, Underfitted, I think, is a nice content creator on YouTube for this sort of stuff. And I kind of like that name, Underfitted, from a machine learning point of view. But so again, the documents and stuff here are from this video. So I want to make sure this person gets credit for it because it's a really nice tutorial that we're using today. Okay, so we're gonna do some install, and this notebook caused me so much trouble. There are a bunch. So there are later on when we get into Pinecone, there's an update to Pinecone, and I have to have special versions of certain libraries to get this to work these days. And this is why I run into sometime. I try to keep this out of you so you don't have to worry about it. But we install certain libraries, and later on we'll reinstall some libraries with certain versions so they can work with Pinecone. So that's a common problem. So we run this. I've actually just run this now. It installs a bunch of our libraries here. We import them here. We set up our keys. We're mainly going to be using OpenAI's key to do some encoding here, and we'll talk about that. So we actually don't need all of this here, but again, this is just what I kind of use in all of our notebooks here to set up our keys and LLMs. I guess we do use an LLM. So we're actually going to use, in this case, we're using Google Gemini as our generative model there, but we're actually using OpenAI to do what we call encoding. So the OpenAI key will be used later on too, we'll see. So we're going to use LangChain here for this. And again, we're going to kind of review how LangChain works. That's what this tutorial does. So the first one, we have a prompt here where we're just talking about what a template is, a prompt template. What MLB team won the World Series during the COVID-19 pandemic there? So we create that template. We put that into our prompt template. And we're not passing any variables in here. So in a sec, we'll see how we can pass stuff in here, but it's just a prompt. We create a chain here, which is just a prompt going through an LLM. And then we have that chain do a prediction, and we get the results and print those out. It says Los Angeles Dodgers won the World Series during the COVID-19 pandemic in 2020. I don't know if that's true or not. I don't follow baseball, but that's what it says. Okay, so that's our basic system. And then we're going to try to build on that a little bit. So we're going to have our model go to what is called a parser to manage the output here a little better. Because again, if you looked at this output, it's just not very pretty here. So now we have our template. We create a parser. And again, there's different ways to parse it. We're just using what is called a basic string parser here that kind of processes the string and cleans it up a little bit, makes it easier to see the output. So our parser there. Now, and here's our chain. We're beginning to see a chain. So we start with our prompt. And then this vertical line is called a pipe. And it's for connecting things together in a sequence here. So we take the prompt and we pipe it to the LLM, and we pipe that output to the parser. So again, we see these pipes here. And again, you can kind of envision this as I think the idea is that it looks like a pipe with different segments. You just keep bolting things onto this with these vertical lines. So prompt goes to the LLM, goes to the parser. Then once we have this chain, we invoke it here. And again, we're not passing any arguments into it yet. And we print out the results, and we get a little better result displayed. because we have the parser in it. And the next thing we're going to do is we're going to probably put some variables in our template. So, and again, this is going to be a prompt, a font we're going to use a lot today for this template. We're going to say, well, here's some context, here's some information, and here's the question. Answer the question given the information provided. So here's our prompt. And again, this is our second one. So answer the question based on the context below. If you can't answer the question, reply, I don't know. And so again, we'll look and watch. So sometimes it'll actually say, I don't know, if we ask it a question that isn't covered in the context. And then we specify context, and then we'll stick the context in here, and we have the question, and we'll stick the question in here. And so when we run this, so down here, you'll see an invoke. We'll specify the context and the question here. And this is fed through this prompt template here. We have input variables for the context and the question. So again, same sort of chain. Our prompt goes to the LLM, goes to the parser. But now, again, we're feeding in these values. I kind of like this because if I click on question here, it shows that that's being used up here for this. So now we can give it a context. And we're going to start by making the context very easy and make it really simple questions. So Mary's sister is Susanna. And then the question is going to be, who is Mary's sister? So that's the context, that's the question. Any good LLM should be able to figure that out. Given this statement, we can tell that. So when we run this, the result is just Susanna. It can figure that out, and it just prints that out. So you can run that. So this is kind of what we're talking about. We give it a question, and we give it some context that goes to our prompt to create a query. That goes to our model. We get a response that goes to our parser, and we get the answer. So again, you can kind of see why, finally, you know, understand hopefully why we call this Lang chain. It's a chain of things we put together here. So now we can create a more complicated thing here. So like our context can be longer. And eventually we'll have a whole document or parts of a document as our context. So Mary's sister is Susanna. Mary's brothers are Jose and Peter. And then the question is, who is Mary's sister there? And we ask this and we print out the result. So question is, who is Mary's sister? Answer is Susanna. Again, we can run that and see the result. And you can actually go in and modify it. You could change the question here. Let's say, who is Mary's, let's say, brother? I should change it here too, I guess, so it prints it out. And I'll list her two brothers. And again, if I ask, like, who is her father? It's going to say, I don't know here. Because again, it has this context. It has the question. And again, using the context is going to ask the question. And in our prompt, we have it say, reply, I don't know, if we can't answer the question. So we tell it how to reply if the data is not in the context for that. Okay, I'm going to change this back to sister here. And run it. It should know who her sister is. So again, this is the idea. We're going to now build more complicated contexts here and big documents and figure out how we pull things from that. So that'll be what we'll be getting. We're going to just, before we do that, we're going to build a little longer chain. We're just going to say, if you have one chain, you can feed it into another kind of chain. So here's the idea is that if we have our first chain here from our parser, we can then feed that into another chain that maybe will translate that into a different language. So you can kind of combine these all together and we can feed in the language here. So again, we're adding a new prompt. It just says translate this answer to this language. for this. So that's our prompt. And then we're putting this all together. So we have, this is chain 2. We have our chain 1 up here. Here's chain 1. And now we're going to set up chain 2 here. And we're going to specify some context. Again, Mary's sister is Susanna, her brothers are Jose and Peter. The question, how many sisters does Mary have? And then the language, we're going to say translate this into Spanish here. And so we can specify, invoke our chain with all of this information, and we can change it. And then our LLM will plug these things. We'll plug in the context in here, the question in here, and the language in here into our prompts in the right spots. So when we run this, it should tell us here. So I've been struggling with this. My LLMs keep wanting to not just translate it, but talk a lot about translating it. So the one, let me try this again. So right, this side, it said the Spanish translation of one is simply one. So I wanted to say uno here. Try to see it. Oh, and now it's getting really, it really is going to elaborate on this sort of stuff here. But again, the first time I run this, it usually just outputs uno there. So again, it's a little unpredictable what you get. So you should see what you get when you run this. Again, so again, there's just one sister. And again, sometimes that's passed along as the word one, O-N-E, and sometimes it's passed on as a number one, the numeral one. And again, how that gets handled as far as translation differs here. So again, a little unpredictable when we get these long chains going together here. So I've actually tried to update this prompt. I thought this doesn't look, I thought I updated this prompt to be a little more specific here. But I don't see that change must not have been here. So you can actually adjust some of your prompts to make sure it's giving you the answers you want for these. Okay, so that's section 1. And again, in your write-up for part 2, I'm going to ask about these 3 prompts here. And again, what wasn't clear initially was which 3 prompts. The notebook, I've added comments here about the 3 prompts a little bit more. So prompt 1 is this, who won the World Series during COVID-19 there, and how that's set up. So that's kind of prompt 1, and we do that. Then prompt 2, we use this template with context and question, and we ask, give it a context, ask it a question. So that's prompt 2. And prompt 3 is when we're combining these chains. We're keeping our original prompt and then adding it on in this translate text here. So again, we want you to just describe those in a paragraph or so. Here, I've actually broke it down into a set of short answers because I think that might be easier for you to understand. So again, you can use what was originally given to you or use this description. Either one is fine here. Yeah. So yeah, the call is this invoke, I guess. So like, let's go up here. When I say when it's called, I mean like when this is to me is when we call, when we do invokes. Actually, so when we call it, we give it the variables, we give it the context and the question or something like that. So with the basic ones, we just say like predict, or we don't give it any details. And in later ones, we'll give it a context and a question, or we give it, what do we give it? Here we're doing a context, a question, and a language translated into. Yeah, sorry if that's not clear. you can, I mean, you can leave it here, but I think it's useful to edit these a little bit, and modify it, here. Even if you stay along the same themes, you can, change it a little bit to see if it works, in different ways. So, pause. I'm going to pause the video so you guys work on this just a little bit. Okay, I'm going to go on to part two, section two here. And so we've been looking at the context, and we're just typing in a short context like Mary's sister is Suzanne, our brothers, Mary's brothers are Jose and Peter. But what we want to do is use big documents. So that's what we're going to try to use. And so what the next section is supposed to show you is that you can't just use a big document. It'll be too big. Unfortunately, AI has gotten a lot smarter in the last year, so this actually will work. But it won't work for all size documents, here. So, and I'll just note the original video used a YouTube transcript. So they used an OpenAI system called Whisper to convert audio into a transcript and grab that transcript here, and set that all up. But we're not going to do that. I find that awkward and slow. So we're just going to bring in a document here. So you can, again, remember this is similar to what we did with the LLMs. Remember when we looked at, not the LLM, like Notebook LM on Tuesday, or custom chat GPTs? We could open up a Notebook LM and we could add sources and we could add documents to it. And we're going to do kind of the same thing here, and add documents. And so you can add, whatever document maybe you did on Tuesday, you can do that again. Or I'm just going to bring in the student handbook and use that here. So that I need the student handbook here. I need to upload the student handbook over on the left side. But I don't have the student handbook here. Well, actually, I did because I already did this, but you probably don't have the student handbook here. Let's delete it. So you won't have the student handbook over here. So I'm going to go to my drive here and look through this. Here's a bunch of different documents. I'm going to grab the student handbook, and I can get it in either PDF form or in text form. I'm going to grab it in text form. So I'm going to click on that and download that. I'm just going to right click and show download. I'll go to my downloads folder. So I'm going to download to my local computer, and then I can upload it here. So, and then here I'm going to click on the little upload button and upload that handbook here. And again, if there's some other document you want, you can just put your document name here and upload that document. It has to be over here in your files. Here, so you can click a little file, it has to be over here. And then I can run this, and it won't give me an error, hopefully, because I have whatever document it is over here. And we've read that in. And it should print out the first 100 characters or so of it. Now, the next section is supposed to show the error here. And so we're supposed to run the next section. It's not supposed to work. But when I run the next section, things work fine. The question, we load in the entire student handbook, and then we ask, can students drink alcohol in their dorm rooms? It's that's somewhere in the student handbook, and it says yes to do that. Now, why is this working when we said it wasn't going to? It says the model will return an error here. So it just, this stuff is growing. So like, question is, how big is the student handbook? If I open up the student handbook in Word and look at word count, the student handbook is 21,000 words. So that's about 20,000 tokens. So that's a big document, 20,000 words. That's a lot in that handbook for that. And a year ago, you could only give like LLM like 1,000 words or 4,000 words at most there. But nowadays, some of the LLMs are taking 128,000 or up to 1 million tokens or words here. And Gemini is certainly one of them. And right now I'm using Gemini for this stuff. So I can take 20,000 words and just dump 20,000 words into this, which is just crazy to me that I can do this. But right now I can. But again, that's only one document, and we're going to want to feed a bunch of documents. So when we're done, we probably have more than 20,000 words in this document. I mean, more than 120,000. So we might hit that limit. But just so you know, this actually does work amazingly well with long documents, as long as they're not too long. So again, where it says this model will return an error because the document is too long, the context is too long, not so much today here. Okay, so again, especially when we're working with multiple documents, we're going to split that document up. And that's what we're going to do. We're going to take our document, they had their transcript, we're going to do our different documents, break it up. They're calling these documents here. I'm going to call these chunks here. We're going to break it up into document chunks here. And then we're going to find the matching chunks and send that with our question so that we won't send all the chunks of the document. So basically, we're just cutting it up like into pages and sending the correct pages to here. So we're going to install this, or we're also going to, I have some as PDFs, so I'm going to read that as PDFs, and I'm going to have 3 documents. And again, this mimics what I did with my Notebook LM. I brought in the course schedule as a text file. I brought in the catalog as a PDF, and I brought in the student handbook here. So I'm going to do the same thing here. Now, in order to get this to work, I need to upload or download and upload all those things. So again, from my source documents, I'm going to grab the schedule and download that. I'm going to grab the catalog. Oops, and it takes a schedule. I'm going to download that. And the catalog, and I'm going to download that. It takes a sec because, especially with these longer documents, the Google scans them for viruses and stuff like that. Okay, so I download them and I want to upload them. So I want to have all these documents. In fact, right now you can see this error. It can't find one of those documents here. So I'm going to then upload those documents here. So here's my, see, the catalog I want to bring in, and then the course, my class schedule. Have I downloaded the Scholastica class schedule? And bring that in here. So again, I want to upload a couple documents here. And again, they can be like PDFs or text files. And then I want to run them. And again, here I'm opening up the documents. And you don't have to do these same documents. You can do other documents if you want. Here, we're specifying, we're opening them up. And then we're putting them all together in one big long document. The handbook, plus the catalog, plus the scheduled text. And I think that's probably long enough where we could feed that whole thing into our LLM. That's going to just be too big for things. And again, it'll take a while to bring these all in and have these all read in by these readers here. And again, they have to be in your notebook over here. So you have to upload them here. So. So once the documents are loaded in, we're going to process them. It, it's interesting. It says there's 352 documents loaded when we really only loaded 3. And I believe the thing is that with PDFs, they bring in each page as a separate document there. And that makes sense. I think the catalog is about 350 pages long. And then the handbook is another document, and the schedule is another document. And text documents come in as one. So I think that's why we have this. But now we have this all together. We're going to split it into parts, and we use a text splitter for that here. So here's an example. So we're splitting it into 100 100 token chunks, and there's an overlap of 20 here. So you can see there's some formatting weird stuff with this, with capital letters, it looks like. So it takes a little bit to understand this, but here's the student handbook code of conduct there. So there's 100 letters, 100 token or words. I think it's only 100 characters, I guess, there. And the last couple is policy library, the last 20, and that's the overlap. So the next one starts with that here and continues on till it gets down to code of conduct here. And so again, these will show each one, and it talks about procedures here, and then the next one will start with that. So every chunk is taken, but there's an overlap between chunks. Now, in reality, you don't want 100 character chunks because again, you'll be dividing it different places. We're gonna more often that you want to be a page. A page is probably like 1,000 characters or more here. So I'm going to do 1,000 chunk sizes and overlap of 100. And I'm using this because this is what the tutorial used last time. To tell you the truth, if I were using this today, I'd probably use chunks more like 10,000 and have less chunks there. But we'll stick with this. This will work fine. So our document is split up into 2,840 chunks of data. And again, if we change this to 10,000 character chunks, then it would only be 200 chunks that we'd have to search from. And I think that's certainly still manageable. So, okay, we divide it up. And now we're going to we have all these chunks. We're going to have to find ones that match our question. So if we ask about the alcohol policy, we have to find chunks in our documents that talk about the alcohol policy. You know, if I ask, can I drink in campus? Now, the questions are, like if I ask, can a student drink in their room? The pertinent thing is the alcohol policy. But, you know, how do I figure out what words to search for from my query in my other thing? Or how do I find the relevant documents? I just can't take a word or a couple words in my query and try to search for them in my document, because again, I might be using the word drink. Can a student drink? Here, not mention alcohol, but in the student handbook, it talks about alcohol and consume alcohol. And we know that consume alcohol and drink, you know, if we ask college students, can you drink and consume alcohol? Those are the same. But again, the computer doesn't necessarily know that by default. So we're going to do what is called embedding. We're going to take the question and convert it into numbers, and a vector embedding. And then each chunk, we're going to convert it into numbers, a vector embedding, so that it kind of encodes the meaning. This embedding will kind of encode the meaning of that chunk of information. So here's where we use OpenAI to do the embedding. And for now, we're just going to try a simple thing. We're going to encode, rather than our whole document, we're just going to encode who is Mary's sister as our embedding. And again, we generate, this is what that embedding looks like. It's a vector, which is just a sequence of numbers. So it is actually a sequence of over 1,000 numbers. So that sentence is converted to 1,000 numbers. in the same way, and then what we'll do is like we'll take a page out of the student handbook. Every page will get assigned a vector, 1,000 numbers that represent that page here. Well, even not 1,000, 1,536. Every chunk will be assigned 1,536 numbers to embed it here. So that's what these are. So now we can embed a bunch of sentences. So we're going to embed a bunch of sentences. Some of them are going to be similar to what we want, and some of them are going to be different there. And then we're going to try, once we have these as numbers, we can just see how close these numbers are. So if we are in a grid here, and you have two numbers in a grid, you can just calculate the distance between them. And there's different ways of doing this, but one way, especially with higher dimensions, we use something called cosine similarity. So we'll use that as our distance. So we're calculating cosine similarity between this stuff. So let's look at our sentences here and find out how similar a sentence is. So our original query is, who is Mary's sister? And the first sentence is, Mary's sister is Susanna. So that is very close to that. So sentence one will have a cosine similarity very close. Cosine similarities, I think, go between 0 and 1. And so that's 0.92. That's very close there. If we ask something else, like Apple just released the iPhone update on May 4th, we ask that, if we have that as a sentence, that's sentence 4, that is not so similar. It's a similarity of 0.6 there. Now it's in English and it has English words and so it is actually quite similar compared to some other phrases and stuff. So 0.6 is not like, 0.1 or something very low, but it's still not close to 0.92. Now, I'm just going to visualize this with a little graph here. So again, this shows these different sentences, and we're comparing it to our sentence, our query, who is Mary's sister, and we're going to try to find which chunk is most closely related to that there. And again, this shows that Mary's sister Susanna is way up here, is a good match. All the other ones are not so good of matches. Some of them are better. Pedro's sister, mother is a teacher. Again, talking about someone's relative here. So sister and mother, somewhat related. So that's a little higher here, but that's not great. And again, now we can try a different query. So what if we tried the query, when can I update my iPhone? And we have our sentences here, and we display those. So we ask, when can I update my iPhone? We have Apple just released an iPhone update on May 4th. That has a really high match here, and the other ones don't. So again, we encode all these sentences into vectors, and then we use this cosine similarities to measure how similar they are for that. And so more similar ones will get a higher score. And so that'll let us, we can go through our whole data, all of our document, and say which ones, or which pages match our query, and only grab those pages of our document here. So that is what we're going to do here. So to do this, we're going to store all of our queries and stuff in a database. So now, some of you have taken database management, our 3107 course. So you've taken that? And what did you learn? How did you store databases in there? What language? SQL sound familiar? Did you learn SQL in that? And tables, you created tables and you had keys and that sort of stuff. That's all good. We're not using any of that in here. You can just take all that and throw it away or just set it aside. You'll use it maybe some other thing, but not today. So we're using a special new database called a vector database or a vector store database here. Because again, we're just storing these numbers and retrieving these groups of numbers very fast here. And so we're putting this in a vector store or sometimes called a vector database. Sometimes called a graph database too. So a similar sort of idea. Okay, so we take our document, we split it up into chunks, we embed each of these chunks. So each chunk has a vector, a number. So again, that's what we are seeing up here. Like here's the vector for whose sister is Mary. So everyone has a vector. And we're going to store all these vectors in a vector store. And then once we do that, if we have a question, we can go to the vector store and say, which of these chunks are most similar, and just grab the most similar chunk or chunks. So we have to do some install here, and then we're going to create our, eventually we're going to use our database, our documents to put this in here, but for now we're just going to do some sample sentences. So Mary's sisters, Susanna, John, and Tommy are our brothers. Patricia likes white cars. Pedro's mother is a teacher. Lucia drives an Audi. You don't. What do you drive? Okay. Drives a Toyota. Okay. We got to make sure we have correct data in our database here. Okay. And Mary has 2 siblings here. So again, we're storing that in here. And then we're going to ask it to search for which document is most similar to who's Mary's sister. And we have this display here. And again, this isn't very clear, but it shows these numbers here. So 1 is 0.9, 1 is 0.91, 1 is 0.90, 0.8, 0.76, and 0.74. So who is Mary's sister? The top answer is this one, 0.91. Mary's sister is Susanna. So that's the closest match. The next one, 0.90, still a good match, is Mary has 2 siblings. So again, that would be useful, might be useful in answering this there. And the next one is John and Tommy are brothers there. And again, the fact that Lucia drives a Toyota barely made the cut here because it's not that relevant to who's Mary's sister for this. And again, when we do these similarity searches, we can specify a K, which is how many documents to return. So even there might be more documents here, we can change it. So if we only want the top 3 documents, we could say K equals 3, and it will only give us the top 3 documents here by scores. So again, in your write-up, it should be asking you about this, right? It should be asking you vector store. What does this document, what does this mean? Again, and each one of these is the score of how, so the higher the score, closer to 1, the more relevant that document, or in this phase, that sentence is to our query, which was, who is Mary's sister? Okay, I'm going to pause and see how we're doing as far as questions and stuff for a sec. Okay, I'm going to go back here again. So if you remember, we stored, and again, we are just storing sentences in this vector store. So we stored a bunch of sentences there, and we learned that we could just ask the vector store, what are the top 3 closest documents that match, or sentences that match, and here I said with K equals 3, you could say what's the top 10 or 5 documents that match this query the closest. And it'll look at the numbers and the distance between, every sentence is encoded in a set of numbers, and I'll compare those numbers to calculate a distance and find out which sentences are the closest. So now we can put this, well, we can do that. We can put this into a lang chain here. So we can create what is called a retriever, and we can ask who's Mary's sister, and it will retrieve the matching pages, the closest pages for that there, and we can feed that into this. So we're going to create this and create a template. Again, we're going to use the same sort of template where we give it some context, we give it a question there. We're set this up here, and we can ask it a question based on some context for this stuff, and it should be able to answer. Like if you ask what color is Patricia's car, it'll say white for this stuff. Now I'm trying to figure out where we set up the context here. And if we ask it what car does it drive, it says a Toyota. Okay. So in order to do this for real, without just these toy sentences, we have to load all of our documents into our vector store. So we're going to create a new vector store, loading in all of our documents that we loaded in earlier. We're going to create our chain here that's going to use those documents. Again, this will take a while because it has to create a vector store from all those documents there in code, and that's a lot of information that has to be encoded and stored in this database. And then we can ask it questions. So given this vector store, retrieve the relevant documents or parts of the documents for questions. So again, we can ask questions like, what course is required for a history major? And it based on the provided context, the required courses for a history major include, and it hopefully is pulling this from the catalog here. That does okay. And I can ask, here's another question. Can students drink alcohol in their dorm rooms? And it says, yes, alcoholic beverages may be used in private rooms of a student apartments by those of legal age. And then like, what computer courses are offered during fall 2025? So, and here it says, I don't know, because so again, the question is should it know that and read that in? So sometimes the way our documents are coded and set up isn't working correctly, and that's the case here. I looked at it, I couldn't quite figure out why. I think the problem is that I've got the fall schedule here, but it is just a table of numbers, courses and numbers, and it really doesn't know what those are. It's not a great data source there, and it's just pulling out some pages there. So I'm not sure what this is. I wonder if I asked it what CIS course is, if that would be a better result. No, that's not doing it either. So again, sometimes even though the data is there, you might not be querying it, or your data might not be stored correctly. But again, this idea that in a business, you could set this all up and you could have it answer questions. This is the idea, like most businesses now have chat bots or things like they have their fix-up manuals, their repair manuals, or their instructions. All this stuff will be in a document repository, and you can then chat with an AI at their website to ask questions about it. And it should be referring to the documents that it has for that company and answering questions, that aren't from the, it's not just asking the internet or searching the internet for this, is actually searching these documents. The last thing we're going to do is try to set this up in Pinecone here. What is Pinecone, you might ask? So again, these vector databases are relatively new, and there are different companies trying to set up these. So Pinecone is a relatively new company here that is trying to just set up vector databases for people to use, or companies to use, to store their information here. We're using it because their pricing, let's see if their pricing model has a starter set that's free. And that's what we like free there. So that's what we have here, is just this free level here. And I don't think we'll push it too hard. I think we'll be fine with our level of service for that. So I've set up a Pinecone database. In fact, let's just go to the video so we can watch that. How do you set this up? I'm going to create an experience I'm going to call it YouTube. So again, with Pinecone, what you do is you go there. Let's see if I can do this too. You have to create a login. And again, often you can use your CSS login, your Gmail login for this. Let's see if I can log in here. I'm just going to use my Gmail, my Google login, my school login here. Okay, so you have to log into Pinecone. And then you're going to need to create what is called an index. This is like a database. So we're going to create an index. And I created one called CIS 3115 rag here for that. So you create an index. So that an index is like its own database. So that's what it's saying here. It's creating a new index. So once you create your index, you have to specify how much each of their data, each of your encodings, how big it is. And different models will use different encoding links. And again, if you remember when we looked at our encodings, where did we encode these? Where was Mary encoded with those? Now here, we're using OpenAI embedding to encode these. So who is Mary? And it generates this set of numbers. And there's 1,536. So that's the dimension. Every document we store in here is going to be represented by 1,536 numbers. And it has to match. And we can only store documents that are encoded in that format in here using this OpenAI embedding. And so that's our next thing, is we have to specify the dimensions. And again, he's doing the same thing. See, here's his 1,536 he's entering into there. Okay, so then once you get your index created, I'm just going to reuse this one there. It'll set this up free. It'll have it in some region. So this one's based in the United States because I'm based in the United States here for this. And now I can bring in documents here. I can add documents, records to my list here. And I think in the free version, you can have like 10,000 records or something like that here. And again, basically each chunk of data, if you remember, when I chunked my data, I did 1,000-word chunks. And so I ended up with 2,500 chunks. So because again, I brought in the catalog, or I mean the catalog here. So each so here's a bunch of things about the catalog, and I also brought in the course schedule. I don't actually know if I did the course. It doesn't. It has last year's course schedule in it because I haven't updated it. I was just thinking, and other things. So again, you can add your documents to this list here for it. These encodings for it. So I've done that, and I think that's kind of beyond the scope of this class to do something like that. Here, let's go back to our video. Okay, so you upload your documents. Right. So then in our code, we specify, we'll have to specify what index. Let me get back to this section 5 where you're at. So to specify things, we need the name of my index here, and we also need an API key. Again, to access these services, I need an API key generally. So again, most of these companies will let you get API keys somehow. And so if I go under here, that's not it. I'm trying to remember where my API key, well, here, API key. So here's my different API keys. You should not share your API keys. So I actually generate lots of different API keys, and I usually then delete them here after I'm done. Looks like I haven't deleted these, but I have to be more careful. Other places that have my credit card. This one doesn't have my credit card, so I'm just on the free level anyway. Okay, so I have an API key there. So we specify that in here, and then we can use our Pinecone system here. So again, I have to do some install, and again, I have to, I had trouble getting the newest version of Pinecone working with some of the other libraries. So I found online a version of Pinecone with some of the libraries that seems to work correctly together. So I'm reinstalling just those versions. I'm setting this up here. Now, this authenticate, I'm not sure, this will have me, well, we'll show it. It'll have me log in. And I'm not sure, I don't think you have to do that here. So you might not have to do, you might be able to delete this authentication because you will have my API key down here. And I don't think you can authenticate. I'm not sure how that's going to work here. So we'll wait till this all loads in and we'll show you and we'll try to see how it works. Okay, it's gonna ask me to connect to Pinecone. I'm gonna skip over that for now and just go down to here and see if I can just run this stuff. Because again, I should have an API key. I should be able to do that here. And then I should be able to go that. So the authenticate, I think you can skip over for what we had. I had that here for some other stuff, but I don't think you need that. So now we're going to try a query, and we're going to ask the database to find the top matches of it. So here I'm going to run this. My query is, so I create a query, can students drink alcohol in their dorm rooms? I then have to embed that, convert it into a vector of numbers. Then I query the database and I say, give me the top 5 matches, closest matching documents here from Pinecone there. And then I'm just printing those out. So here's my thing. And again, it's just printing out this, there's 1,000 characters here, but it's just printing out the first part of this. Residencies and a roommate who is legal drinking, da da da. So again, you can see some of these. The Benedictine tradition of hospitality. Okay, doesn't seem like that's that close a match. This one talks about alcoholic beverages. That looks like a little closer match here. So again, and it's finding every match has a score here, a cosine score. And again, the closer to 1, that is the better match it should be. So here I'm just grabbing the top 5 ones, matches, and just displaying them. But now we're going to feed this into our database. We're going to create our query, go to our vector store, and again, retrieve the top documents, and we're going to put those all together in one big context document. So I'm going to grab a bunch of chunks, the best matching chunks like this, and then I'm going to concatenate them into one kind of, basically when I'm going out to the database and saying, give me the pages that are most related to my query, which is can students drink in their dorm rooms, and it grabs those pages. I'm grabbing those pages together and basically stapling them, putting them together as one document, the best pages. And now I ask my database, so given that context and the query, can a student, and it should respond, yes, students of legal drinking age can drink alcohol in their private rooms of the student apartments. Yeah. Now I can try different questions here. Now, to do the question, I have to go up here and do the query up here and change it up here because I have to, again, send that to the database to get the correct matching documents. So maybe I'll ask a different question like, does the college offer a history major? So I go up there, grab the documents that relate to that, go down here, use that context and the query, and it says, yes, it does. Gives me a nice, clear answer to that query. So just like kind of before, where we were doing this with a set of sentences, here we are doing it with the set of sentences and finding which sentence matched our query the best. Now we have these whole we've taken our document, 3 big documents, we've chunked them into 1,000-word chunks, 1,000-letter chunks maybe. Now we're asking, we stored that in a vector database there, and then we can take any question, go out to the database, find the corresponding chunks or pages, bring those back together, and then given that context, ask our query or question and get a result here. So that's how these RAG systems work. And that's how, basically what's under the hood of Notebook LM. Here's our documents we've brought in. They've chunked these, they put these in a vector database most likely. And then when we type in our query, it searches that vector database, pulls up the corresponding chunks, uses that as context, and then generates an answer for us. So that's your job. So see if you can get through the write-up for this stuff. See how that goes. And again, one note, the project, even though it's an even week, the project's not due till next week. You can do it if you want to get started on it. You can certainly do it now, but it's not due till next week here. And actually, I need to change this. Next week is Easter, so it's not, and we have Monday off here. So I'm going to make everything due Monday night, the 21st there. So all the due dates for next unit and the project will be that week. Okay, I'll hang around. If you have any questions, ask me. Pause this.